All right, everybody, we are back for another subsection all about data. And we've moved from our concept to our measure to our variable. And now we're going to talk a little bit more about kind of data aspects and data factors and pieces of data and how they might be organized. So, first thing we're going to talk about are the four levels of measurement. Okay, there's nominal, ordinal, interval, and ratio. Now, the nominal level of measurement means that you can count things, but you can't rank things, right? So, in other words, like the number of people with any given hair color in a certain class. There might be, 10 people with black hair, 10 people with brown hair, 5 people with blonde hair, and 3 people with red hair. Just picking numbers out of them. But you can't rank those. You can't do any math with them, right? You can't do like two blonde hairs and a red hair equals a brown hair or something. That makes no sense, right? And there's no ranking that you can do where like clearly brown hair is on top and then red hair that it doesn't make any sense. All you can do is count the categories, right? With ordinal level of data, you can rank them, but the distance between each one is not necessarily the same, right? So if you go to a fast food place other than Starbucks and you want a drink, there are kind of three choices, right? Small, medium, and large. And you can rank those. Large is bigger than medium, and medium is bigger than small, but the distance between them is not necessarily the same. The distance between small and medium is not necessarily the same as the distance between medium and large, right? Similarly, the people who come in like first, second, and third in a race. First was clearly first, second was clearly second, third was clearly third, but the distance between first and second is not necessarily the same as the distance between second and third. For interval level of data, I have only ever in my entire life, and I have gone searching, found two good examples of the interval level of measurement. And that's temperature in Fahrenheit and temperature in Celsius. Where we can rank them, and the distance between each value is the same, but there's no meaningful 0 point. The 0 point isn't the absence of the thing, right? So 20 degrees is hotter than 10 degrees in both Celsius and Fahrenheit, and the distance between 0 and 10 and the distance between 10 and 20 is the same, but in neither case is 0 the absence of heat. It's not the absence of temperature, right? If you want a scale of temperature that does have a meaningful 0 point, you have to go to Kelvin. Kelvin, where 0 Kelvin is, in fact, the absence of heat, right? And then finally, we've got the ratio level of data. And with ratio level data, you can rank them, the distance is the same, and there is a meaningful 0 point. So like the amount of money in my bank account, right? The different distance between $0 and $100 is the same as the distance between $100 and $200. And $0 is the absence of dollars, right? So that's ratio level data. And when you're measuring some concept, you're creating some measure, creating some variable, you want to use kind of the higher order, meaning lower on this list, level of measurement that you can reasonably use, right? So if you want to, one of your variables is how somebody did in a certain race, instead of using first place, second place, third place, which would be the ordinal level of measurement, you want to measure that as the amount of time it took for them to go from the start line to the finish line, which would be the ratio level of measurement, right? So if you have the choice, you want to use the more detailed, more kind of advanced, lower on this list level of measurement if your concept and measure allows you to. Now, if you're going to do some kind of survey or interview, you're going to ask people questions. And there are two different kinds of questions you can ask. There's closed-ended questions and open-ended questions. Closed-ended questions are where you're given a certain set of choices that you must pick from, right? So like a multiple choice test or a pen and paper survey that asks you to, of these 5 choices, which one would you pick, right? So, but there's a pre-selected set of answers and you have to pick one of them. In an open-ended question, there's an infinite number of possible answers, right? So an interviewer might say, hey, tell me about your childhood. That is an open-ended question. There's literally an infinite possible combination of things that person could tell you in an answer to that question. So each of them have their positives and negatives. Obviously, the open-ended questions are going to be used more in qualitative analysis. Closed-ended questions are going to be used more in quantitative analysis, but not necessarily. If you're going to use closed-ended questions, though, and provide the survey or interviewee, the survey taker or the interviewee with this set of answer choices they must pick from, you need to make sure that the answer choices are both mutually exclusive and exhaustive. Mutually exclusive means there's not 2 different choices that are both equally correct. Right? So if somebody asks you, what's your, what is your race? And they provide, white, black, Hispanic, Asian, etc. And one of my parents is white and one of my parents is Asian. Well, I now have 2 answer choices that are perfectly correct because I am both white and Asian, or I am both black and Hispanic, or something like that. So if I have 2 answer choices that are equally correct and I have to pick one of them, then that question's answer choices are not mutually exclusive. Exhaustive means we have to make the answer choices complete. In other words, everybody has to have at least one correct answer choice, right? So the reason I put this image on this slide is because it is a closed-ended question where the answer choices are mutually exclusive, i.e. there's no 2 of those that overlap, but they are not exhaustive. So if you are ages 1 through 9, or 31 through 34, or 51 plus, you do not have a correct answer choice there. So it's a closed-ended question that has mutually exclusive answers, but it's not exhaustive. It doesn't have exhaustive answers. There are people out there that are not going to have a correct answer choice to pick from. Now, we're going to talk just a little bit here about construct validity and some of the subsets of construct validity. So remember, construct validity is all about how you are taking these concepts and turning them into measures and variables, right? We've gone through this whole process of taking our research question, identifying concepts, defining the concepts, creating measures, creating variables. And construct validity is about how well our end result actually measured that concept that we had to start with, okay? So there's a few different kind of sub-issues here, or things we need to examine here. The first is face validity. And face validity is kind of the easiest one of these to understand. It's, does it sound good when you say it fast? Right? So if we want to measure somebody's recidivism, that's our concept, is recidivism, and we get to the end of our process, and the ultimate measure is, well, how many pecans did you eat in the last week? That doesn't make sense. Why would those 2 things have anything to do with each other? That lacks face validity. Like, it doesn't even make sense in any kind of realm of possibility, right? Content validity means, do our measures explore kind of the full range of our concept, right? So, for instance, if we want to know how much violent crime somebody is committing, but our measure is only whether they've committed a murder or not, that is measuring a part of how much violent crime they're committing, but it's not measuring the full range, right? We'd have to know not only how much murder they're committing, but also how much sexual assault and how much armed robbery and how much aggravated assault and all those things, right? So if we're only measuring how much murder you're committing, we're not measuring the full range of how much violent crime you're really committing. And then there's criterion validity. Criterion validity refers to whether some measure you have corresponds to other measures you have that we know are good, right? So if we want to measure somebody's violent crime by whether they've been arrested for one of those violent crimes or not, you know, murder, sexual assault, aggravated assault, armed robbery, etc. That's our good measure, right? But now we want to introduce another measure. We want to know if they're, how often they punch a wall in frustration to the point where the drywall breaks. That has face validity. I can see how that might theoretically correspond to how much violent crime they're committing, right? It's not completely out of the realm of possibility. But now what we're going to do is we're going to get a whole big group of people and we're going to use both measures. And we're going to see, you know, their arrest records for violent crime, and we're going to see how often they've, in their lives, that they've punched a wall and broken the drywall. And we're going to see if those vary, those two measures vary at the same rate. And if they do, you know, if one is high, the other tends to be high, and if one is low, the other tends to be low, we would say that those two measures have good criterion validity. Okay, but if the two kind of go up and down in our sample without any seemingly correspondence, then they don't have good criterion validity. And again, this is all about how well do our measures really cover these concepts that we're trying to measure. Okay, that's all construct validity is. And these are just a few of the many kind of sub topics under that bigger umbrella of construct validity. Now, the last thing we're going to talk about here in this section is reliability. Okay? And there's a difference between validity and reliability. And it's very similar to the difference between accuracy and precision. Now, in my off time, when I'm not creating these wonderful video lectures for all of you out there in internet land, I like to do archery. Right? Where, you know, I take a bow and arrow and I shoot an arrow at a target. High accuracy means I'm getting close to the middle of the target. Low accuracy means I'm not getting close to the middle of the target. High precision means all my shots are clustered together. Low precision means all my shots are kind of spread out. And the two are different. I can have a nice tight cluster of shots, as this image shows, with you know, where they're clustered and very close together, but not very accurate, right? So reliability is the same kind of thing. Validity is essentially the same as accuracy in this example, whereas reliability is more about the precision. Not necessarily how well are we doing against reality, but how well is what we're doing compared to the other things we're doing, right? And there's multiple different ways to talk about reliability, right? You can do what's called test-retest reliability. And that means we're going to do some measure, and they're going to wait a while, and then we're going to do the measure again and see how closely those match up, right? And if we have good test-retest reliability, they'll give us either the exact same number or a very, very similar number every time we do the measure, right? Inter-item reliability means that if we're doing those multiple measures, right? If we decided to measure compassion with hours given to volunteer work, money given to charity, and, you know, a self-report questionnaire, inter-item reliability means those three things should all kind of correlate together. As one goes up, the other should go up. As one goes down, the other should go down, right? Alternate forms reliability means we're going to kind of ask the same question, but twice. And we're going to see how well those compare to each other. So my first question might be, how old are you? And you'll give me some numerical answer. And then I'll ask, what year were you born? And those two should be essentially the same thing, right? Or easily turned into the same thing. And if those end up being very different, we know we have a problem there. And then finally, there's inter-observer reliability, right? So if I show a whole big group of people a cartoon, right? Donald Duck and Bugs Bunny, and then I ask them to watch this cartoon, and then I say, okay, guys, I want you to count up how many instances of violent action you count in this 3-minute cartoon. And then I let everybody watch the cartoon, and they all write down a number. If that number is very, very similar among all our observers, we have a very good inter-observer reliability. But if one person says 9, and another person says 34, and another person says 18, and another person says 2, we have really bad inter-observer reliability, right? So hopefully, ultimately, our measures will be both valid, i.e. accurate, and reliable, i.e. agree with each other, right? And there's some overlap here, right? So inter-item reliability sounds very like the criterion validity from the previous slide. But they're also testing two different things, validity and reliability, right? So that's the end of this section. Thank you so much for watching. I'll see you in the next one.